Hi everyone, this lesson is about the equation for a rectangular hyperbola. So we can see the equation here, y equals a over x take h plus k. A is the vertical dilation factor, which we've seen before with parabolas and other polynomials. H is the horizontal shift, left or right, and k is the vertical shift. Again, we've seen these things in other contexts, so let's see what this graph looks like. Now, to begin with, I'm going to start with a equals 1, h equals 0, k equals 0. So my graph would literally be y equals 1 over x. It would be the easiest one we would have. So if I take an x value of 1, then 1 over 1 gives a y value of 1. If I take an x value of negative 1, 1 divided by negative 1 gives a y value of negative 1. Not really enough to go on for drawing yet. Let's go to an x value of 2. 1 over 2 gives a y value of a half. If I had x equals negative 2, 1 over negative 2 gives a y value of negative a half. Interesting. Let's try an x value of 0.5. 1 divided by 0.5 gives a y value of 2. Let's try negative 0.5. 1 divided by negative 0.5 gives a y value of negative 2. So my hyperbola is some sort of a curved graph that comes down here like this, and then on the negative side of the scale it'll be curving downwards like this. Now that represents the most fundamental, the parent function, if you like, the simplest possible rectangular hyperbola. The graph continues this way, getting closer and closer to but never reaching the x-axis. It continues upwards, never quite getting closer and closer, but it would be forbidden to put x equals 0. If we were to let x equal 0, y is not defined. There is no y-intercept of this graph. The vertical and horizontal axis, if you like, the graph never touches them. We call them asymptotes. Now that's that one. Let's now consider what would happen if I did a vertical scaling factor. So perhaps, I'll switch to blue. Let's do a different graph. I'll do y equals 2 over x. So my value of a is 2. Now, I can pretty much just go to every one of the points I've already done and multiply the y-coordinate by 2. So instead of this point here with a y-coordinate of 1, staying in line, I would go to a y-coordinate of 2. Instead of this one with a y-coordinate of a half, staying in line, I'd end up with 2 times a half, or 1. If I was to go to this one, I'd have to go all the way up to 4 somewhere. This one would go to negative 2. This one would go to negative 1. This graph would be like that. It's literally a vertical stretch. So remember, A is the vertical dilation factor. That's the blue graph. Do I have green? I'm going to try a equals negative 1. So I have the formula y equals negative 1 over x. So again, compared to the original red graph, look at the y-coordinates every point, multiply them by the value of a by negative 1. So instead of the value 2 there, staying in line, I would be at negative 2. Instead of positive 1, I'd be at negative 1, and instead of a half, I'd be at negative a half. So that one would sit under there. Then this one would be, instead of negative 2, it would be positive 2, positive 1, positive half, and this one would be in here. So that one would have the same shape as the red one, but it would just be inverted, because a, being a vertical scale factor, can also turn things upside down when a becomes negative. So that's a little bit of an idea of what the value of a does. Now, h and k. Let's go to a fresh diagram. I'm going to pick one that says y equals, let's go 1 over x plus 1 minus 3. Now in this one, I would say that a equals 1. I would say h, the horizontal shift, is, remember, it's x take away h, so I'd have to write h is -1, and then k is the number at the end, including the negative sign because it's plus k. So there's h and k. Let's start to draw my graph. Now my vertical asymptote was the y-axis, but I have a horizontal shift of -1. So I'm going to have my vertical asymptote 1 unit to the left. That's the line x equals -1. My horizontal asymptote was the x-axis, but it's the vertically shifted downwards by 3 units. So I'm going to have the line y equals -3. Now it's almost like, I'm just going to move that a bit further down. It's almost like that point is now the origin of my graph, whereas the original one, of course, was over there. That was the line x equals -1. Now remember what we had last time. We had, if you took from that central point 1 step to the right, it was 1 step up. 2 steps to the right was half a step up. Half a step to the right was 2 steps up. And then this thing, these red dotted lines would be the asymptotes in this case. And there'd be a mirror image version of this down here. The most important point would be that one in the middle, which is at coordinate -1, -3. And then to mark in some points on my graph, because vertical dilation was 1, then it's the usual 1 step across, 1 step up. So that would be at 0, and 1 step up is -2, and then 1 step left and 1 step down. So that's -2, -4, just for that point there and there. And then I've sketched in the rest of the graph. So hopefully that makes a bit more sense now. Thanks for watching.